In this lesson, you will learn to find values of functions using function notation, as well as how to find the composition of two functions. So the first question is, what in the world is function notation? Well, all it really is another way to write y equals. So for example, if you had the equation y equals 3x minus 4, what I can do instead is write this as f of x equals 3x minus 4. So this notation right here, f of x, is considered function notation. And how you would say that would be f of x. So it's just another way of writing y equals. Now the question is, why is this important and how do you use this? Well, mathematicians are all about being succinct, being very quick, and not having to write more than what is needed. So for example, if you had this function, f of x equals x plus 2, and you were told to solve for y when x is 0. Now you could write out that whole phrase, solve for y when x is 0. Now with function notation, what this does is it gives us a way to say that entire phrase very quickly. Where instead of saying solve for y when x is 0, what I can do is anywhere I see an x, I'll put a 0. So I could just say solve for f of 0. So solve for f of 0. So this would be the same thing as what I just said right here. These are the same thing. So for solving purposes, you just plug a 0 in for x, and now we have, instead of x plus 2, we have a 0 plus 2, which would just be 2. So y would equal 2 when x is 0. So that would be my solution. When x is 0, y is 2, and that's what it means. Now it could also say solve for y when x is negative 2, or some other number. If x were negative 2, you'd put a negative 2 in for x. So instead of f of x, I can say f of negative 2. And then in place of x plus 2, I can have negative 2 plus 2. So f of negative 2 would just be 0. And what this means is that when x is negative 2, y equals 0. So notice it's much quicker. Instead of writing out the whole phrase, we could just say it very quickly with f of 0, or f of negative 2, or f of whatever. So it's kind of weird to get used to, but that's all it means. It just means y equals. Let's look at another example. Here's f of x equals x plus 2, and solve for f of negative 5. Now remember, what this means is that it means what is y when x is negative 5. So notice in the function notation, in place of the x, I'm putting in the negative 5. So if it just says, what is f of negative 5? Well then, I just plug a negative 5 in for x. So instead of x plus 2, I now have negative 5 plus 2, which would be negative 3. So what that means is that when x is negative 5, y is equal to negative 3. I'm going to do one more because this is kind of weird to get used to. Using the same function, once again, I could ask, find f of 4. So what that means is that what is y when x is 4? So notice in place of the x, I'm putting in a 4. So in place of x here, I'm going to put in a 4. So instead of x plus 2, I have 4 plus 2, which is equal to 6. So what that means is that when x is 4, y is equal to 6. Now there's different ways to represent functions, as we just said. This first way is actually a really unique way, and I've personally not seen this too much, but you could see it written like this, where you have f and then a colon, then x, and then an arrow. And that's the same thing as saying f of x equals or y equals. So it's all the same thing, but I just want you to be aware of the fact that this right here is the same thing as f of x equals, and it's the same thing as y equals. Those are all the same thing. So one more, here we have g colon x with an arrow. What that means is g of x equals, or it can be the same thing as y equals. And by the way, I'll point that out now. The f does not matter if it's an f or a g or an h or a j or some other letter. The f is just showing that you have a function of some sort. So just like how we have different variables like x and y and z, and they're just kind of placeholders and just showing that you maybe have different variables being represented. Same thing with f and the g. It does not matter the letter that we use per se. It is just naming, so to speak, the function. Now lastly, I'm going to deal with what's called composite functions. And this particular lesson, personally, when I first learned Algebra 2 back in high school, this part of this lesson confused me the most in the entire class. But if we recognize function notation, then we can handle composite functions. Because the math isn't really too difficult. It's just kind of weird to get used to. So composite function is if we have two functions and we have like a function inside of a function. So for example, here we have two functions. We have function f and function g. We have f of x equals 2x minus 1 and g of x equals x squared plus 1. And you might be asked something like, what is f of g of 2? So what we have is we have the g function inside of that f function. So this is basically doing what we just did with function notation, but doing it twice. So if we just think through basic arithmetic, if you have two sets of parentheses, you're going to start with the innermost parentheses first, and then work your way out. Same idea here. We're going to start with this g of 2, the innermost parentheses, and figure out what is g of 2. Well, what is g of 2? Well, since it has the letter g, I'm looking at this g function right here. So all we do is we replace the x here and here with that 2. So what is g of 2? Well, instead of x squared, we have 2 squared plus 1, which is going to equal 5. So this whole expression, the whole g of 2 right here, can be replaced with a 5. So we're going to plug this 5 in place of that entire expression with a g of 2. So instead of f of g of 2, I'm going to now say f of 5. And I do the same thing again. What is f of 5? Well, I look at now the f function because we have an f of 5. And all we do is in place of the x right here, we're going to plug in the 5. And in place of x here, we also plug in a 5. So f of 5 would equal 2 times 5 minus 1, which would be 9. So f of 5 would equal 9. So my solution, f of g of 2, would equal 9 right here. So it's two parts to get to my final solution. So basically we did what we did at the beginning of the lesson, but we do it twice. We do the g of 2 first, and then we do the f of 5 second. Now I'm going to show you one more with the same functions, but instead of f of g of 2, I'm now going to have instead g of f of 2. So same process where I want to start on the inside. Start in here with the innermost parentheses first and find f of 2. Well, what is f of 2? Well, I have an f here, so I'm going to look at the f function, and in place of x here and here, I'm going to put in that 2. So f of 2 would be 2 times 2 minus 1, which would be 3. So f of 2 is 3. So in place of that f of 2, I can put in this 3 right there. So instead of g of f of 2, I now have g of 3. Well, what is g of 3? Well, now I look at the g function, because there's a g here, and in place of the x here and there, I'm going to plug in the 3. So instead of x squared plus 1, I have 3 squared plus 1, which would be 10. So my solution, g of f of 2, would equal 10. That is my final answer. So once again, it's 2 parts. Start in the innermost with the f of 2, and then work your way out and do the same thing again, now with the g of 3. And your final solution, g of f of 2, would be 10. And that concludes our lesson for today, and we will see you next time.